we are on page 4, right in the middle. We're starting to see catabolism of indispensable amino acids. I did 1419, I'm going to unhighlight it just to show you that you can get using.
And so now we're getting specific.
Yes, so now we're getting specific. And the mechanism, this book is very good in the sense that we're going to memorize a bunch of stuff now that's going to help us in 417P. Like they picked out the mechanisms and the amino acids they want you to follow because they match up with what we're doing in vitamins and minerals. So what we learn now will help later because we're going to talk about folate, which is B9, and this has to do with folate. Okay, so this is figure 1420. You guys are going to memorize part of this, not the whole thing, because I know right now it's like, oh, this molecule is terrible. Okay? This is methionine. This is an amino acid. Let me zoom in. Right? Alright, we're going to start up at the top. This is amino acid, methionine. So you already learned how to draw this. You're just going to remember how to draw it again. Okay? We're going to follow what happens to it. So I'm not worried about the names of these enzymes. Okay? I just want you to follow the pathway. So you can ignore all these little things over here. Okay? Because we're going to do the rest of these enzymes later. Alright? But I want you to follow the arrow. So take out this word, and take out that word, and take out that, and all that. So we're going from here, L-methionine, to here. Now you don't have to draw all these crazy end groups. Okay? I don't want you to draw any of that. I want you to draw, you can put just a bubble or a Q or an X, and then I just want you to draw this part. Because we are tracing what happens to methionine when it gets attached to this big giant thing, which is called S-adenosyl L-methionine. So I'll write this on the board in just a second, but I'm going to walk you through it first. All right? Then we're going to draw another arrow, because we have this group right here. And then we're going to move to S-adenosyl L-homocysteine, which is this group here, and the change is that methyl group is missing. All right? And again, I'm going to put it on the board. And then we're going to do the last arrow, and you'll notice that the R group goes away. And we've gone from methionine up at the top, which to homocysteine. Why do I care about this? What am I thinking about? Why are we memorizing this 4-step pathway? Because this is how you get methyl groups. We are going to talk about what we do with methyl groups when we talk about folate. Epigenetic modifications oftentimes involve methylation. You have to be able to get methyl groups to turn off gene production. If you can't turn off gene production, you have a different way, or gene, I guess we should say gene translation, right? And also gene production, but we're not going in that direction. So let's just talk, in other words, yeah. So, okay, so we're not doing DNA stuff. So let's just talk about translation. You can put a methyl group on there, and then you can stop producing certain proteins. If you stop producing certain proteins, you're not making certain enzymes. But if you can't turn that off, you're making all the enzymes all the time. That mechanism requires methyl groups. So we are memorizing these 4 steps so that we understand where our methyl groups come from. So, I'm going to put this on the board, okay? Okay.